Okay, you can write it like this, or even you can write it like this. Okay, you can write it like this as well, no difference over here. Is that clear, students? Okay, so let us now take the truth table for this. Okay, the truth table is high and the output is low. The output is low when any one output is low. Sorry, when any one input is low. Okay, so what we when both the input are low. Okay, so it's clearly visible that this is double input, this is two input or double input circuit. Okay, if I draw the truth table, so how does the truth table looks like? So the truth table will have an input part, it will have a output part. The input part is a, b, and the output is y is equal to a plus b. Okay, just check the values. You will find that when the input is 0, input A is 0, input B is also 0, the output is 0 plus 0, 0. When input A is 0, input B is 1, you will find that the output is 0 plus 1, 1. When the input is 1, the input B is 0, you will find that the output is again 1. And when both of the inputs are 1, okay, when both of the inputs are high, the output is also high there, okay, that is 1. Clearly it is visible that when any of the input is high, the output is high, and when both of them are low, only then the output is low or the output is off. Okay, so if I draw the time graph for this, so this is A, this is B, and this is the output Y. Okay, so this is the graph lines for A, the graph lines for B, and the graph lines for C. Okay, what you will find from here? You will find from here that, just a moment, yeah, you will find from here that when input A is low, input B is also low, input B is also low, the output is also low. When input A is low but the input B is high, okay, the other input is high, the output here is high. When the input A is high, when the input B is low, you will find that the input is high again. And when the input A is also high and the input B is also high, the output is higher. Okay, so this is the time graph that is given here. Okay, I hope the truth table and the time graph is also clear for you. Okay, now what if I talk about the electrical realization? Okay, just remember it from the realization of the NOT gate and the AND gate. From this NOT gate, I can say that for this circuit, okay, the circuit will behave like a NOT gate when the key is placed in parallel. Okay, it will behave like an AND gate when two resistors, when two keys are placed in series with the circuit. So what about the electrical realization for the OR gate? Okay, so for OR gate, the electrical realization is something like this. Okay, you will find from here that the circuit will behave like an the circuit will behave like a OR gate when it is connected to, okay, the first there will be a battery. Okay, that battery will be connected to what? It will be connected to a bulb. Okay, and there are two keys that are placed in parallel with each other. There are two keys that are placed parallel to each other. What does that mean? It means that if I am having two keys, key K1 and key K2, okay, I can say here that when any one of the key is closed, okay, when any one of the keys closed, you will find that the current will complete the pathway and the bulb will glow. Okay, when both of them is off, then definitely the bulb will not glow. Thus output is also off. But when any one is on, the circuit will be completed. Even if both of them is complete, even if both of them are on, the circuit will remain on only. Okay, so this is the realization that you can feel. So here we were having two input, so therefore I am having two keys. Okay, placed parallel in series, placed parallel in series with circuit. Okay, the keys are parallel in themselves, but to the circuit they are in series. Okay, is that clear? Okay, so with this we are done with the fundamental gates. Okay, what are the various fundamental gates we discussed? The very first fundamental gate was NOT gate. NOT gate is based on inverse operation. Okay, it is a fundamental gate made up of transient. Okay, it is made up of transient. Let me write it again, transient. Okay, the Boolean expression for this is y is equal to a naught. Okay, what is the circuit symbol? So the circuit symbol is this. Okay, and how can I so this is the truth table, this is the time scale graph, and this is the electrical realization, where since I am having one input, therefore one key, and that key is placed in parallel with the circuit. Coming to AND gate, so AND gate is based upon product or multiplication. It is a fundamental gate which is made up of diode. The circuit symbol is like this. You can easily see that here there are two inputs and the input goes into the plane surface. Okay, whenever you find that there is a plane surface and okay, basically AND, okay, you can hear this out, A and D, so you have to draw it D. Okay, you have to draw the symbol of D. Okay, two inputs will be like this and the output will be like this. Is that clear? So yeah, this was the expression for this. This is the based on multiplication, therefore it is A into B. This is the truth table, this is the time scale, and this is the electrical realization. Since I was having two input, therefore two keys are required and they are placed series with each other in the circuit. Okay, you should note here that when the output is high when both of the inputs are high. Otherwise, if any one is also low, the output will remain low. Okay, coming to OR gate. So OR gate is also fundamental gate that is based on addition. Okay, it is double input gate. It is made up of diode. Okay, the symbol, the Boolean expression for this is y is equal to a plus b. Okay, it is addition. Therefore, you can find that this is looking like OR. Okay, so you have to think that it is thus convex surface from both of the sides. Just simply assume that this is convex surface from both of the sides, like this as well and like this as well. Okay, so yeah, this is the circuit symbol. Okay, this is the truth table. You can see this is the time scale and this is the electrical realization. The important feature from here is that the output is high. The output is high when any one is high. Okay, the output is low when any of the when both of the inputs are low. Only then it is a low circuit. Okay, the output is low. Let us now move to the universal gate. Can you let me know what are the universal gates? What were the universal gates? So we were having two universal gates. Okay, the first one is known as NAND and the other one is your NOR. Okay, so let us start with first NOR. Okay, I will be starting with NOR gate. Okay, you can see that NOR is made up of two things, NO and OR. Okay, N and OR. So can I say that this N represents NOT and this OR represents the OR gate, right? So does it mean that I am taking NOT plus OR gate or OR plus NOT gate? What do you think? Am I taking NOT plus OR I am taking OR plus NOT? What do you think? Okay, so if you find that it is NOR, so you will be thinking that this is NOT plus OR. No, it is wrong. It is OR plus NOT. If I say that I am having two input A and B, if I am writing NOT and OR, that means A naught plus B naught, A naught, okay, B naught, and they are being OR, that is plus. But this is not which is happening. This is OR plus NOT, which means A plus B whole bar. A plus B whole bar. I hope that is clear. Okay, that sounds perfect. So what is our NOR gate? NOR gate is basically a combination of two fundamental gates, the OR gate and the NOT gate. Okay, well, so let us take it. So I will be telling that this is a universal gate. This is a universal gate. Okay, so why these are called universal gate? Because all gates can be formed using this. Can be formed using this. Okay, well, what is the Boolean expression for this? So I have already mentioned, but still, what is the Boolean expression? So you'll be writing that the Boolean expression is y is equal to a plus b whole bar. Okay, so if you use the theory of the De Morgan's theorem, can you write that what is the expression for this? The expression will be a bar dot b bar. Okay, I hope that is clear. Okay, so this was about the Boolean expression for this. Okay, that sounds perfect. Now what is the circuit symbol? Circuit symbol. Okay, this circuit symbol is something very important for you. Well, how will I represent this? Basically, this is OR plus NOT. So first draw an OR gate. Okay, this is my OR gate. And what is the NOT gate? So NOT gate looks like this. Okay, since I already have this part here, okay, in different form, I will not take that, but I don't have this circle over here. So I will be using that here. And this is something like this. This is your NOR gate. What is this? This is your NOR gate. I hope that is clear. Okay, you can write it like this, or even you can write it like this. Okay, you can write it like this as well. No difference over here. Is that clear, students? Okay, so let us now take the truth table for this. Okay, the truth table. So the truth table looks something like this. This is my input. Okay, this is my output. Okay, what can I say about input? My input is A and B. Okay, let us take something here, and then my output is what? My output is NOR, which is equal to y is equal to a plus b whole bar. A plus b whole bar. Can I say that NOR is basically opposite of OR? So let me write the OR gate as well. That is y is equal to a plus b. If I take my input as 0, input A 0, input B 0, y is equal to a plus b, that is 0. So you will find that the output here for NOR gate is 1. If this is 0, this is 1, this is 1, and this is 0. If this is 1, this is 0, this is 1, and this is 0 again. And if both is 1, you'll find that this is equal to 1, and this is equal to 0. Okay. NOR gate is completely opposite to that of the OR gate. In OR gate, if you are taking the OR gate, okay, then what you observe? You observe that here you will find that whenever I want the output to be high, so you have to take both the inputs to be low. When both the input is low, only then high output is there. Otherwise, if there is a single high input, then the output will be low automatically. Okay, let me write it down. Okay, output is high when both input are low, when both the inputs are low. Okay, and you'll find that here the output is low when both inputs are high. Okay, I'm sorry, when any one input is high, so this is the distinguishing feature between the two. Okay, in OR gate, if any one is high, the output will be high, but here if any one is also low, the output will be automatically low. Okay, so I hope that is clear from your side. Okay, what if I draw the time graph for this? So if you want to draw the time graph, that is upon you. Okay, well, that is not required, but still I will be drawing just for a while. So this is equal to, okay, sorry guys, yeah, okay, I get my,
it's not effort, it's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.